Okay, so in this video, I will show how to wrap it all nicely in the Yocto project, and we'll show a layer that takes care of Weston and also of automatically connecting to Wi-Fi. And I'll wrap it up nicely in a distro so that we don't need to modify local.conf for that. So let's start with the result. And if I go ahead and see that on the device, and what are the open services? We see that automatically we have this nice thing here, which this one is RDP and this one is naturally VNC. I'll connect to the device and it will ask me because it likes to for the password. So we also set within our layer and the Western password, and I'll show you how that's done. So this is what I like on my device. I showed that there is like a CPU info here that I had. Okay. I actually I flashed it, I started recording and there wasn't sound. So the credentials are already there, everything is good. But this is the device, I mean there is no mistake about it, okay? So that's what we have. We also have RDP and it's easier to work with SSH. So I'll just show you how things look there and what we have on the device. What are the things that we put? So the things that we put, let me just get the phone. So the things that we put are essentially under XDG Weston. We have our TLS stuff, and I already put like a video that showed how to generate these materials, and I put this in GitHub as well. So you can look at that. There is a link from the repository that will be shown in this video. And we have like this VNCSH script, only that these things now we will do automatically, like the running of the servers, we'll do it within Weston. So we also modified Weston ini, and we did two things. We enabled the module screen share. You can ignore require input true. I just like doing it so that if there is no fdev on the devices, I showed like several videos ago, then Weston will not come up and we'll have like the terminal list. Otherwise, we will have Weston coming up, but will not be able to input and will not be able to work. And the second change is this, like the screen share model. This should work like I think from Weston 13, it definitely works in Weston 14, which is the target of these videos. So these are the things that we have here. We also have WA paths, okay? And what I also put here is something nice in Unity that connects to Wi-Fi. I will show the script later. It doesn't do too much. It uses WPA supplicant with the password that I showed, and then runs UTHPC. Previously, I created manually such a service. Now I do it automatically via the mechanism that I will show very soon. But the nice thing here is that the mechanism that I will show automatically creates. I gave this separately for a reason. Yeah, so they automatically create the start and stop script like those links, okay? So if I go ahead and just do an ls-l on this fellow, it will point to our file, okay? So these are the things that are being done here, setting up VNC automatically, and because we set the Western Union, we set the certificates and everything. And the second thing is automatically connecting to Wi-Fi. If we achieve both of these things, then we can work with our device upon flashing it. And we flashed it with fast boot, and I showed it before. So these are the things that we show. Keep it open just in case. The tool itself is built like this, like the image itself is built like this, like machine equals qcom arm v8a. Previously, it was inside the local conf, and distro, which I will illustrate, I just read another Yocto distro. If you're new to Yocto or to Yocto distros, you can learn a lot from this video. So I'll create a distro in order mostly to select PAM, but that was a requirement, but also for some other things, like selecting this Wi-Fi configuration creation. And then we do bitway core image Weston. So before, when I had like my Yocto image that I edited manually for some configuration file, we at least had the dependencies for Weston and VNC, and we add the things that are commented out here. So we add, first of all, machine somewhere. So let's look for it. So we add machine equals qcom arm v8a, which is no needed if I put it in the command line. Okay, otherwise you must select it. Okay, and the distro and the recipes in the meta-western remote layer that I will illustrate, they take care of selecting the things that are commented out here, which were adding to the Weston package config VNC and RDP, adding to the product niche VNC, that's this image installed here, adding distro features PAM, pluggable authentication modules, and in the niche VNC that was added here, adding TLS support. We talked about it, about all of it in the previous videos. So now everything here is commented out. So essentially what one can do is just, I believe that I put it like in the README of the distro. One can just clone Yocto project, add the layers they need if you build like for Qualcomm Meta QCOM. If you build for your own things, just add like this layer, okay? And after adding the layers, you can just do OE init build end, which will generate a default local conf, and then you use like the machine and distro and build our product. So what do we have like in the machine and the distro? By the way, both of them, I added them to GitHub. So the distro itself, I'll skip that readme and copying. I created, a distro is a layer, and I created it with a bitbake layer tool. And in order to have a distro, what we have is essentially a layer conf, because it's a layer. And in this particular case, I do not add any BB or BB append files. So it will give me a warning that you can ignore. We could alternatively just delete this file, this line of the BB file. Now, the second thing we need is under conf to have a distro folder. And then we need to have like the name of the distro and conf. And this is how we call it. It can be an arbitrary name. The description is a description, okay? Versions overrides mean that it overrides POKI. And we usually specify the overrides like with the most specific in the right. So this is like the simple Western remote distro. And because we want to just use POKI almost as is, but add very minor things that are this distro features append PAM. And the second thing, distro extra RDPends append hacky WLAN connect, which takes care of automatically connecting to the Wi-Fi. And it's quite hacky. This is why I named it like this. Because we just want to add this to POKI, then we can do like the distro overrides. And we need to require conf distro POKI.conf, and then it is POKI one-to-one with our additions. So this is all there is to know like about the distro. It's not intrusive. We do not need to touch local conf, and it's very elegant. The other ways to actually provide distro features for PAM, which is needed for using VNC and RDP in Weston. The other ways are specifying a machine conf, which is less elegant in this way because it's not a machine feature necessarily, although we can claim it's like for the Qualcomm, but then we need to override the machine, and I did not want to get into it. I want to make it like very simple, or to override the local conf. So creating a distro is the most elegant thing that we can do, okay? And a distro is a layer, so we just add it to our layers just as is. So let's look at our layers, okay? Look what we have here. We added meta OE before for the NIC VNC. We added meta Qualcomm because I'm using like the Qualcomm device. And the new layers that I'm adding is what we just saw, meta-weston-remote-distro. And this new layer, meta-weston-remote, that we actually saw references to some of the recipes in it, that is the hacky W10 connection in the distro.conf file. So let's look what our meta-weston-remote layer provides. And our meta-remote Weston that we have is actually in GitHub, and so is like the distro. Okay. Now, one of the things that it provides is a dummy file for WPA supplicant that was created in this particular way, WPA passwords and so on. So if you want to have your own Wi-Fi connectivity, either have your router, like your base station, have the exact same SSID and password, or generate it here with WPA passphrase and your network and NID, okay? And you'll need to modify this very particular file in this very particular path. And then if you include this recipe that is hacky W10 connect, then you will have Wi-Fi. Okay, so sorry, that's not what I meant to do. So this is like the file. I made like a nice README for it and a video to this link. If the video comes well, then it will appear here. So we saw this connect. So let's start with this actually. So I'll just show it from GitHub. So we saw the WPA path. We already saw this file on the target itself. I didn't really need to have like start stop. I just wanted it to be more similar to like a service. It could be very orthodox and put here like the comments that are from the Linux starter base. You can see this link over here to see how things are. I just needed it to work, but it will support restart and stop, so it's nice. We put your double-click supplicant in the background. The configuration file is what I just showed. It's a WPA path that I need to copy into the device. I'll show you how. And the interface is W10. Of course, this can be customized, but because I want to make it very fast and very easy to use, this is the hacky WM0 connect. Then we do DHCPC. So if you have a DHCP server, you're all set, and then you'll have Wi-Fi connectivity to it because we already showed the dropper is already function and active there. So that's it. We don't need to look at WPA paths, but we need to see how things are copied. And here there are very nice things. So we prepend this directory as opposed to the other recipes that we will see or saw in Weston. This is not a BB append, it's a BB file. So we must specify license and checks into it. So that's what we do. We use a free and available license, the MIT one. We prepend to file extra path this dir. These are the files that we will be copying, connect to wifi.sh, and will be copied in a very interesting way, which I will explain, and WA path. And the idea is that upon installation, I'll just show how it is. You can ignore these notes because they are to show some things on screen, okay? Maybe I'll delete them. Upon installation, several things will happen. We already saw install construct, and they are pretty straightforward. They come from the install mechanism in Linux, install like binary, and every project uses it more or less. So we are going to actually go ahead and copy to etc that is conf.dir the file wpass, okay? And here I deliberately did not add systemd support because this is one of the exercises in the Yocto Project training. So we check that the init manager is not systemd, and if it's not it, we copy connect to wifi.sh to the init directory. Now, this does not explain the S990 connect to Wi-Fi service. It doesn't also explain the K20 Wi-Fi service. Just like there were, let's look at rc0.d. Just like there are like start services, there are also kill services. So here we will have under K20 connect to Wi-Fi, which will also be a link to inid connect to Wi-Fi.sh. So it does not explain it. Now I will explain it how this magic happens. So we only have this connect to Wi-Fi installed under init connect to Wi-Fi.sh, and then we inherit the magical update rc.d. If you want to enable support for systemd, you will also inherit like systemd related class. And with these two lines, init script name connect to Wi-Fi.sh, this is the one that will be under @c initd, and init script params that say start, this is the round level like S990, install it under RC5D and RC2D, and stop, this is the level K20, and install it under 0, RC0D, RC1Z, RC6D. We have these three lines, and automatically the file that we copied to initd is going to be included, which is pretty nice. So this is nice, and this is the entire recipe for the Wi-Fi, okay? And it's complete, it works, you can easily modify it to your needs, and that's for it, okay? Put it under recipe connectivity because it has to do with connectivity. Now, for the Western ones, let's start with the easier one, Meet VNC. So before I showed you the things that I commented out, and the things that I commented out, were also package config append p and neat VNC that we'll see in the Western recipe, but also image install append. Okay, so once we need to put the image install append somewhere, all right, that is, we need to present a dependency, for example, in rdepend. And we also need to take care, once we have it, of the package config with TLS, which is what we have here on the neat VNC bb append. Package config append equals TLS, this time without the PN. Okay, we don't need PN in neat VNC because the recipe is in it. So that's all for neat VNC, just configuration. What do we have for Wayland and Weston? So for Weston bb append, we added dependency, the runtime dependencies in neat VNC with rdepend. And we add to the package config, we add here VNC and RDP, because we need both of them. So that's pretty nice, and that works nicely for us. Now, this means that they will build, but we wanted to provide some files, everything under TLS stuff, and Weston ini. That the only changes, I just took it from the Open Embedded Weston init recipe, okay? But I modified the Weston ini file so that I put screen share. I put require input, as I mentioned. You don't have to do that. And in screen share, I modified the command and made it start on startup. So let's see what we have here. So on the recipe itself. So the recipe itself, what we have is, that's Weston init, the bb append again. We add to our package these files. Okay, so the file construct is meant so a package manager will have like all the files that it provides in an organized way. So we add it here, and the other files that we add would be the Weston ini, and it's a configuration file. So we also add it to the conf files. It's more organized like this. It's more orthodox like this. Other than that, the regular things. We want to use this dir, so we add files extra prepared, and then for the src URI, we're going to be using this. All the files that we need under TLS stuff and the Weston ini. Now, important, because my user ID is 1000 and the Weston user ID is 1000, I can get very annoying warnings when I build a recipe if I do some change on or install or something like that, which is something that I'm going to do. So keep package name plus equals host user contaminated will prevent this annoying warning from appearing. It's super safe. It's not a hack. It's a good thing to do. Okay, so what else do I have and what else do I do? I mentioned that we need Weston and Weston to connect via VNC. I don't know why we need it, but we need it. So the idea is that we're going to add a user, and there is a user add param on the Weston init.bb recipe, and we override it. The only change here is this line, -p. which provides a password. Now the password has an algorithm, everything between dollars. The backslashes are necessary. If you don't make them, you will not be able to log in. It needs to be escaped. Then a random salt that is being used by the crypt util. You can use crypt to see what's going on. And this is like a hash that was generated from the salt, the algorithm that I think is a SHA-2, it is SHA-512, and the password itself that is essentially Weston. This is how I generated it, but every time you run this command, you will have different outputs. So I generated with OpenSSL password -6 Weston, and it gave me this nice, without the backslashes, it gave me like this nice output. So I copied it, and because I did that, then the equivalent one ended up on the Etsy shadow file. So I can log in as Weston, and this is why I could also log in with VNC there. For RDP, I do not need it. So that's the addition, user add param, and it's created these modifications there. The only thing I need to do other than that is just copy the files and wrap it up. So that's what I do with the install. So this creates the directory, TLS stuff, and this sets up the files, and it sets the permission for like the certificate, for the key. The key should be actually 0400, but okay, let's make it writable. It doesn't really matter. And what we have here is also like this VNCSH script that we had and don't really need. And last but not least, we have the Weston ini file. So if we don't want to have it, we can just not copy it. And if we want to modify it, so we can start like screen sharing only with Control-Alt-S, we will modify the Weston ini file itself. So having shown all of this, we're pretty much done. This is a complete and sound way to add screen share to Yocto. And on the way, we also added like automatically connecting to Wi-Fi. And you don't need to change your local conf. You build with machine equals, in this case, it's Qualcomm for Snapdragon, for Dragonboard, the QCOM RV8, and the distro is the distro we specified. Core image Weston, we flash it like to the Qualcomm device with a fast flash rootfs, and then the ext4 file after like unpacking it. And that's it. We have screen share. We have recipes in Yocto. We have distro in Yocto. And you can use it to create the same things for your own devices. So I hope you find it useful. And this wraps up the remote desktop and VNC inside Yocto, or inside a derivative of Yocto, or inside Qualcomm, inside Chroot. And you can go ahead, get the Yocto project, clone Poki, add the layers if you have a Qualcomm device, get it to Meta Qualcomm also, build it, and you can use like the ext4, the resulting ext4 partition, like I have, to maybe to run another PCG build-offs, maybe to just root to it, and you can experiment with a lot of things. And this is a very good way to learn how to customize Weston by having just like a local, maybe under root, local Weston ini file that you will VNC or RDP to it, and you can modify the behavior. And after you're convinced that you know everything and got the result that you want, just port the result back to your device and build it properly. So I hope it has been useful for you, and thank you for watching.